Welcome to our presentation on our deep dive coding surveys and the data science approach we took to understand them a little bit better. We are Team Lambda. We'll start with some presentations. My name is Ben Holdridge. I've been coding for several years, and I started this boot camp in order to launch a career into data science.
My name's Catherine Laguna. I came to this boot camp to expand the skills that I used to build data-enabled solutions over the last 20 years. My company and I developed and delivered custom data solutions to underserved industries such as tribal, nonprofit, and education. A portfolio of that work can be found at dosolutionsgroup.com. I plan to use the skills I have learned here to refresh and expand my capabilities as I look for new opportunities.
I'm Elijah Martin, and I took this boot camp with the intent on building a background in coding and software development. I've been working with computers since I was 7 and have a background in building computers and hardware in general. I have a strong interest in networking and network security, but to achieve this as a career, I have to build a stronger background in the software field. I have to convert the things I learned in this course and others at C&M to an avenue into this field.
Okay, now that you've been introduced to us, here are some of the tools that we used in our project. So on the right-hand side, we have our import statements, if any of those are familiar to you. Python was our coding language, and Google Colab was our development environment. Google Colab is a cloud-based program built upon Jupyter notebooks. So a little bit about what you're going to see today. We'll go over our problem definition, how we gathered and cleaned the data from the surveys, some things we explored, and we'll bring you through some processing techniques that we use to analyze the data a little deeper. And then we'll end with some of our conclusions and recommendations.
This is a sample of a deep dive coding exit survey. This sample outlines the orientation of how the questions were presented. Almost all of the written responses were paired with a Likert scale partner. A Likert scale is a measurement of agreement with a statement or question. There were a few questions that asked for a lone written response, and these questions were optional, so only the Likert scale answers were mandatory. This is important because it means that most of the sentimentality data is in the Likert scales. This survey has been posed to all graduating students since 2014 in fluctuating forms, and the questions have varied from year to year, and this caused some issues which we will touch on later.
Our project is an unsupervised learning problem with natural language processing aspects. In our case, our goal is to collect and review and analyze the deep dive coding exit survey responses and report to C&MI on the general student satisfaction trends. Let's review our overall process methodology. From a high level, we obtain data from a data source. We wrangle the data to prep it for processing and analysis. Then we perform our analysis using different methodologies that we learned. Our data involves 299 responses to exit survey questions given to C&MI students from the years 2014 through 2020. We received the data as multiple Excel worksheets, and the question responses were in 2 forms: Likert scale with a range from strongly agree to strongly disagree, and written responses. Next, we need to do some data cleaning. That is, we cleaned up the responses. An example of this is time spent out of class. The answers varied greatly and appear to be actually a translation problem from the survey tool to Microsoft Excel. To correct this, we label encoded or translated to create distinct groupings. Next, we converted the Likert scale responses to numerical ranges. More will be described later in the presentation. And then we performed general review, or what we call exploratory data analysis.
In the bootcamp, we learned many different methodologies to apply to any given problem. These methodologies fell into 2 categories: supervised learning and unsupervised learning. Supervised learning is defined as a problem that has specific outcomes or a dependent variable, and those outcomes are influenced by features or independent variables. We then use the outcomes to train the learning model. Some supervised learning techniques we learned include linear regression, naive Bayes for classification, as well as decision trees and other gradient boosting tree techniques. Unsupervised learning is the opposite, a problem with no specific outcomes. Some unsupervised learning techniques we learned include word vectors, nearest neighbors, and a couple of clustering methods such as k-means and hierarchical. Because this problem involved both unstructured data and no distinct outcomes, it's an unsupervised learning problem, and we elected to use the following techniques: sentiment analysis on written responses, category mapping to contextually organize the data, hierarchical clustering to group by both question and student responses, and lastly, word clouds to visualize term frequency. And let's see what we learned using these methods. This slide outlines the statistics of individual boot camps. The top section refers to the number of students that have attended deep dive coding boot camps, shown as cohort counts, graduate counts, and response counts. The boot camps have an average of 61% response rate, which is an excellent response percentage for any survey. The bottom half refers to questions posed in the survey which are significant with regards to student satisfaction and outcomes. An average of 94% of the students across all boot camps would recommend their boot camp to others, a statistic to be proud of for sure. And the last row shows how much time the student spends out of class per boot camp. Notice full stack responses are 60% of the overall total, which makes sense given it's the longest running boot camp. And the full stack responses heavily influence the outcomes we see throughout our analysis due to that majority. This slide outlines how written responses were handled using Textblob. We have a sample question and some actual written responses to that question. When Textblob analyzes sentiment on an input response, there are two output values: polarity and subjectivity. Polarity is a value on a scale of -1 to +1, where -1 is a strong negative response and +1 is a strong positive response. In this case, subjectivity is superfluous because all the students will be describing their own experience. An example statement that a Likert scale would apply to is, the pace of this course was conducive to my learning. The Likert scale is defined by possible responses, which include strongly agree, agree, neutral, disagree, and strongly disagree. And with the previously discussed numerical polarity scale in mind, we applied a mirrored numerical scale to the Likert entries for use in processing, represented as -1 for strongly disagree, -0.5 for disagree, 0 for neutral, +0.5 for agree, and +1 for strongly agree.
Cool. So to explore these responses in a little bit more depth, we decided to categorize the questions by which ones we determined to be most similar. So here are the 5 categories we came up with. The first one is the deep dive center staff and facility. These are questions about the support staff and the stimulus center itself. Then we have questions about pre-requirements, how students felt coming into the course. Then we have curriculum questions, so questions about the pace of the course, what was learned, and then questions about outcomes, how students felt coming out of the class. And lastly, we had a grouping about instructor questions. So were the instructors knowledgeable? Did they answer questions? Things like that. And the bar graph below shows the average Likert scores for each of these categories over all the years that Deep Dive has been operating. And as we can see, most of the data is extremely positive. More neutral sentiment in that 2014 year quickly rises, which is exactly what we'd expect, kind of a little bit of a learning curve for a new organization. So as shown earlier in the slides, oftentimes the written responses, or I guess all the written responses are optional. So we wanted to know what categories the students were most likely to volunteer written responses for. And as this graph shows, most of the categories fall between 10 and 20% of the opportunities to write a response were taken. The outcome questions received almost twice as many written responses as those other categories did. So students were much more inclined to write responses about their outcomes. They were much more excited about that. Next. Here, we wanted to look a little bit at the pairings of questions. So often questions would come with a Likert question and then immediately after the opportunity to write a written response. We wanted to know the relationship between these Likert scores that were given and the paired written responses. So we used Textblob as described earlier to get a sentiment out of it, a negative, neutral, positive kind of score. And we determined those and paired them up with their Likert response and came up with this graph. So for each Likert response option, strongly disagree, neutral, so on, we have here a violin plot, and it represents the density of the polarity questions that came with it. So where the violin is wider, we have more responses at that polarity. And as we can see, kind of through the box and whisker plots in the middle, which you might be a little bit more familiar with, there's a slight positive trend. So it is actually quite weak though. The correlation is only 0.3. And this is because most of the written responses there, you can see kind of tend towards neutral. That's where those most wide parts of the violins tend to be.
This graph reflects the likelihood of a written response since they were not required. It demonstrates extremely well when a question would get a written response. When students left a strongly disagree Likert response, they had a 60% chance of leaving a written response. Conversely, when a student left a strongly agree Likert response, they only left a written response about 8% of the time. The trend is almost linear, but not quite, and it tells us the higher the student satisfaction, the lower the likelihood of a written response.
The next method we use to analyze the data is hierarchical clustering. Hierarchical clustering is well suited to this task since the data set is small. Only 299 students responded to the survey, and the number of clusters are unknown. Clustering is one of the most common methods of unsupervised learning. That is a type of machine learning using unknown and unstructured data. Specifically, we use agglomerative clustering. This is known as the bottom-up approach, where each data point is a cluster of its own. Imagine we have a number of discrete points like these diver helmets. And then you begin to do distance measurements to each centroid of the clusters. There are other methods like closest point and farthest point, but we use what's called centroid linkage. And we're also using the Euclidean equation to calculate the distance. It is the most common method to calculate distance between 2 points. Lastly, this method continues to search for the shortest distance between any 2 clusters until they're all found. And we have just 1 cluster. Here we'll visualize the cluster cycles. First it found the red one, and then it would find the blue, then the gold, and then the green. And to get the final cluster, the grayish outline would be then the end. Clustering is used to find data similarities. Next, we will see how the questions are grouped by student responses. This graphical image is called a dendrogram. It is how clustering is visualized. This dendrogram labels questions grouped by student Likert scale responses. After applying the agglomerative method, we got the following results. 5 distinct clustering groups with overall averages from lowest to highest from 0.42 to 0.84. Recall the Likert scale, so all these averages are positives. Many are close to what would be agree or above. Upon closer review of the questions in each clustering, we found the following categories. Note these categories are different, but close to the contextual groupings we made earlier in the analysis. Also, the rightmost clusters have related topics. Notice curriculum instructors, and then instructors and curriculum. We found actually upon further review that the center cluster were for only questions that were posed between 2014 and 2017. And then the later years, these questions were presented differently and are represented by the outcomes we see on the rightmost clusters. And then you see that the instructors and the curriculum pulled apart. If there's an area to focus, it might be in the curriculum area on the far right cluster, which had responses that involved all boot camps. Since given after 2017, this will actually lead to one of our recommendations later. But note, overall, the mean of all the response categories were positive. Next, we have a method to visualize term or word frequency in the written responses called a word cloud. This image is a collection of the top 150 words throughout all student written responses for all boot camps through all the years. Non-sentiment words, what are called stop words, are removed. Examples of these are the, I, and numbers. Over the next 3 slides, we created a word cloud per boot camp. One takeaway here, though, is time was mentioned often. Next, we have the full stack web development and then Microsoft.NET word clouds. Notice the full stack image on the left is highly comparable to the last slide. The majority of the written responses came from the full stack boot camp. And you can see here time, instructor, and course pop out. On the right, the .NET, notice there are much fewer words in the written responses, which is why we see much larger words in the visualization. Keywords here are instructors' names, like Brian, and specific boot camp content, like Microsoft and Net. Next, we see Java and Android and digital media word clouds. Java and Android on the left had many words in their written responses. Recall, we are only showing the top 150 terms. So here the words were more evenly distributed. But time, course, and instructor, you can see very obviously. On the right, digital media word cloud, notice that some of the words are larger, like instructor and bootcamp specific content, but the words are smaller because they occur less frequently. Again, though, we see content like digital media and great instructor. Last, we have the newest boot camps, Internet of Things and Data Science, are the most newest ones. They have less written responses because they are newer. And the Internet of Things on the left, here we see a greater distribution of words, but keywords are IoT and the instructors by name. And then on the right, similarly, we see content specific to data science, like data and science, and the instructors' names, Cliff and Kyla.
Right, so some conclusions that we came to. The surveys were overwhelmingly positive, and the pacing curriculums that scored towards neutral quickly recovered. Likert scores were the majority of the data that we were able to use simply because they were required, and so all the students gave those. We did find out that negative Likert responses were much more likely to have a written response paired with them. Some recommendations that we have, we would change the question, how likely are you to recommend this course to others, to are you likely to recommend this course to others? Simply a change from a 1-10 scale to a yes/no format. This would make it a little more consistent with past surveys. We'd also like to confirm the question change. If you did have concerns before the beginning of the boot camp, were those concerns alleviated? That question really had 2 in 1, and so wasn't nearly as useful as we would have liked. So splitting that into 2 actual separate questions is very good. Then we would also like to confirm another question change. This one's how many hours per week have you spent outside of the classroom on this course? The options have now been made discrete, so which is very good, but we would also recommend adding units, so hours at the end. And this is simply to prevent some formatting errors that Excel has with interpreting those as months and days instead of hours. And then lastly, if we could add a question to the survey, we would like to add something with regards to the balance of the pace of the course and something bootcamp specific. So for example, with regards to the pace of the course, do you feel an element of the course needs changing, or is there any content in the course you feel you did not have enough time to learn? I think that would provide a lot more insight on what the students would like changed. And with that, does anyone have any questions?